All right, AB statistics, here we are with section 1.1 and analyzing categorical data. So specifically only the data that can be organized by categories. In this section we will be displaying categorical data with a bar graph, identifying what makes sense, what makes some graphs of categorical data deceptive, calculating and displaying marginal distribution of categorical variable in a two-way table, calculate and display conditional distribution in a two-way table, and describe the association between two categorical variables. So we'll start by stating that categorical variables place individuals into one or more categories. So here we have different radio station types. So you're going to fit in, these radio stations fit into one of these categories. And then along the edge here, all these numbers represent how many of those different types of stations there are. The left table is called a frequency table, so that's just the straight count. And on the right table, that's called relative frequency. So each of the, if I was specifically looking here at the religious category, I would take 2014 and divide by the total, 13,838, to get this number here, 14.6%. So that's just relative to the total, which is why it's called relative frequency. So frequency tables can sometimes be difficult to read. As you can see, there's just numbers absolutely everywhere. Sometimes it's easier to analyze a distribution by displaying it with a bar graph or pie chart, which is also called a circle graph. So these are both appropriate for categorical variables. So what you might do here for this bar graph, I know it's behind the table, but what you might have for a bar graph here is each of the bars would be the height of each frequency. So you could easily compare based on how tall the bar is. And then here we have a circle graph behind the relative frequency table where each wedge of the circle represents the relative frequency of one of the station types. So some good things to do when you are making one of these graphs. When you do a bar graph, make sure that the bars are equally wide. It's sometimes tempting to replace the bars with pictures, but don't do that. Pictographs are not, they're very deceiving. So beware of the pictograph. Make sure your scale is consistent and the width of each of your bars is consistent. Two-way tables and marginal distributions. When a data set involves two categorical variables, we begin by examining the counts or percents in various categories for one of the variables. A two-way table describes two categorical variables, organizing counts according to a row variable and a column variable. So here we have on one side young adults by gender, so we have male and female. So unfortunately for statistics, they really don't talk about non-binary ever, so there's usually just the two genders, so just beware of that going forward, that they're never going to have that third category, which I don't necessarily agree with, but for simplicity, they always just use the two variables here, the male and female. So we have gender or sex, I guess it would be for male and female, versus their chance of getting rich would be the other variable that we're looking at here. So if I'm reading this, I can see that 96 females thought that they had almost no chance to get rich. So the two variables described, I'm going to say sex instead of gender since there's only two, and chance of getting rich. How many young adults were surveyed? So here we're just reading the table, making sure we understand what these numbers all mean. We have total. If I'm looking down the rightmost column, that's the total of each of the rows here. But if we go all the way down, then we can see the total of 4,826 young adults surveyed, all in all. So let's say we had 415 students ranged from age 9 to 17 from the UK and the United States who completed a census at school survey in a recent year. Each student's country of origin was recorded along with which superpower they would like to have. The ability to fly, freeze time, invisibility, super strength, or telepathy, which is the ability to read minds. Use the two-way table to calculate the marginal distributions. So I think I'm going to run out of room here, so I'm just going to extend this page. So if I need marginal distribution, that's going to be out of the total. So it is important that so we only have the categories here. If I looked at the last page, that two-way table had totals running along the right side and along the bottom. So we do want to add these up. So the 54 and 45, this total here is 99. We can label this if we want to as a total. And then 96, 67, 43, 110. And it's important to get this total at the bottom as well. Our total is 415, because when it asks us to do marginal distribution, that is referring to total. So for those who prefer to fly, that's going to be 99 total out of 415 people, which is about 23.9%. Freeze time. There were 96 who preferred to freeze time out of a total of 415, which was about 23.1%. Invisibility, 67 out of 415, which is 16.1%. Super strength, 43 out of 415, or 10.4%. And telepathy, which was 110 out of 415, or 26.5%. Describe what you see. Oops, excuse me. Up here. So then there's our percents. We do have to make a graph, then describe what we see. Okay, so based off what we just calculated, let's make a bar graph over here. Up the side, we'll have our percent for our label. 10, 20. We'll have to go a little bit, almost up to 30%. 20, 30. And then across the bottom is going to be all of our labels. So we have the ability to fly is going to go up to about 23.9%. Since I labeled right next to it, I'm not going to label the bar height. Oh boy, this is going to be a little rough with my lines here. But if you want to label the height of the bar, you can do that as well. Freeze time, 23.1, so it should just be a little bit lower than that one. Invisibility, so notice that they're not touching. Bar graphs do not touch. This is 16.1%. Try to do as equal width as I can here. Super strength, 10.4%. Telepathy, 26.5. Hopefully you can do a little bit straighter lines than I can. That is a struggle. Okay, now we can describe what we see with these very wobbly bars. It looks like telepathy is preferred. Telepathy was the most popular. Super strength was the least popular. Okay, so now we move on to marginal distributions. The marginal distribution, which is what we just calculated. Again, remember I said that that's out of the total. Marginal distribution of one of the categorical variables of a two-way table of counts is the distribution of values of that variable among all individuals described by the table. So this is important about marginal distributions. Okay, so percents are often more informative than counts, especially when comparing groups of different size. So how to examine a marginal distribution: use the data in the table to calculate the marginal distribution in percents. Or make a graph, which is what we did on the previous page. First we did the marginal distribution in percents, and then we made the graph. So to examine, for two-way tables and marginal distributions, what we want to do is examine the, in this case, marginal distribution of the chance of getting rich. Okay, so with examining the marginal distribution of getting rich, so here's the example that we referred to earlier, where we have the male-female on one variable that we're analyzing next to their chances of getting rich. So one way of analyzing that, as we talked about before with the marginal distribution, would be to take the total of each row, so almost no chance has 194 total, and divide that by our total, since it's a marginal distribution, 4826, which is about 4%, and then we did that for each row here. And once we have that marginal distribution calculated, we can come over here to the we come over here to the bar graph, because each of the categories are labeled on the bottom axis, and each height corresponds to the marginal distribution percent. That way we can visually compare that good chance and 50-50 chance are extremely close, and as we can see by the numbers, they're extremely close as far as what the answers were. Okay, so a relationship between categorical variables, a conditional distribution, of a variable describes the values of that variable among the individuals who have a specific value of another variable. So the important thing here with conditional distributions is to select the row or column of interest, use the data in the table to collect the conditional distribution in percents of the row or column. It's not the total this time. And make a graph to display the conditional distribution, either with a side-by-side bar graph or a segmented bar graph to compare. So what that's going to look like: calculate the conditional distribution of opinion among males. So notice that the calculations over here are dividing, so almost no chance. I'm looking here at the 98 and dividing by the male total. So we're examining the relationship between gender and opinion. So the gender, or the sex total, is going to be the number we divide by. So 98 divided by 2459 is going to be the answer for the male almost no chance. And then looking right next door here at the female almost no chance, I'm going to have the 96 divided by 2367. So notice conditional, we are dividing by whatever the condition is. In this case, our condition is gender. Once I calculate the conditional distribution, very carefully notice the total each time is the gender total for each category. Then this is what we call a segmented bar graph. So the total height of the bar is 100%, and each category on the inside, so almost no chance, is blue here. That's corresponding to my answer, 4%. So I have the height of that specific bar about 4%. From there, I have the sum chance at 11.6. So the green builds off of the blue at about 11.6. And once I add all of those categories together, I should get 100. And if you didn't, then you made mistakes with your calculations. So it looks pretty similar, except that the male green section is a little bit smaller and the red section is a little bit bigger. But the other sections look pretty similar. So can we say that there's an association between gender and population and opinion in the population of young adults? Making this determination requires formal inference, which we have to wait a little bit before we can make any conclusions there. But even a strong association can be influenced from lurking variables. There could be something else going on that doesn't directly mean that the reason opinions might be different is because of gender. There could be some other reason lurking around there. So let's do an example. Let's complete our analysis of the data on superpower preferences. So remember that this was our example that we looked at earlier for marginal distribution. Now we're going to look at conditional. Find the conditional distributions of superpower preference among students from the UK and the US, which means our totals are going to be the UK and US totals. So I'm going to take just a second here to add up these column totals so that we have those to work off of. Okay, so you can see that I added those numbers in there. Those are the 2 column totals, since those are the conditions that we care about. So I'm going to come down here and we're going to have to make a conditional distribution for the UK and the US. First one is for flying. The UK, so again what I'm going to look at here is 54 divided by 200 is going to be that, and we're looking at percents for our, to be consistent here, we're going to use percents, which this is going to be 27%. I'm going to go through and do all the UK values. This is 26% for freezing time. Invisibility is a 15%. Super strength is 10%. And telepathy is 22%. And now we're going to go over to the US. So keep in mind, the thing that changes here is that we are now going to be dividing by 215. So 45 divided by 215 is going to be our first US total, which is 20.9%. 20.5%. 17.2%, 10.7%, and 30.7%. So now what we're going to do with those is we are going to make, if we look at the next question here, make an appropriate graph to compare the conditional distribution. So the first example walked us through how to do the segmented bar graph, so let's now do the side-by-side bar graph. Oh my goodness, again with my wobbly lines. So we're going to have all of our categories down here: flying, freeze time, visibility, super strength, and telepathy. And then we're going to have, remember this is our percent, 10, 20, 30. I'm going to go through and do all of the UK numbers in black first initially. So just do, oh my goodness. I'm using a tablet here to write, and it is actually pretty difficult, so that's why these are so wobbly. This is 26%, oh, 15. Super strength is 10, and telepathy is 22. Right next to each of these bars, so the reason they call this side-by-side bar graph is because now we are going to do all of the US right next to it, still under the same category, so 20.9 in this light green color. That way we can see the direct comparison between the black bar, which represents the UK number, and the light green bar, which represents the US number. Freeze time. Invisibility. A little bit higher here. Super strength. And telepathy, that one's a pretty big jump. That one's over 30. Okay, so there's my very interesting bar graph. Is there an association between country of origin and superpower preference? Give appropriate evidence to support your claim. So do we think there's a big difference between these bar graph heights? If the bars were the exact same height, we would say that there is no association. Because some of the bars are pretty different, I think that we could say that there is. We can't prove that right now because we don't have inference. But we can claim, we can say, I think there is. There is an association between country of origin and superpower preference. UK, the reason for this is to back this up, UK seems to prefer flying and freezing time sorry about my handwriting here. And US seems to prefer telepathy. Seems like nobody really cared about super strength, but because there were such big differences between flying, freezing time, and telepathy, I think we could claim that there was an association. Okay, so in this section we talked about displaying categorical data, identifying what can make graphs deceptive, marginal distributions and conditional distributions, and then how to display that data, and then how to describe an association. That was section 1.1 for AP Stats.